In this video, we'll look at the usual pre-processing steps that we go through to take some text data in its raw form and put it in a different form which is more amenable for neural network processing. So, what is text really? What is the rawest form for actual text? Well, really, we should think of text in its raw form as just a long string that contains all of the characters that are contained in the text. So we have an example here where we have just a single sentence represented as a long string, but it could be a whole web page. So the textual content of a web page where the whole string would be all the sentences in order that they appear in the web page in question. So that's the raw format for our text data. And now we'll see a bunch of steps, pre-processing steps that we usually go through to get to represent this text in a format that's going to be easier to manipulate when we want to feed textual data to a neural network. So the first thing that we usually do is that we will tokenize the text. That is, we will identify essentially the words or tokens that are present in the text itself. So, so for instance, for this sentence here, he's spending 7 days in San Francisco. Then we could split it like this. So the first token or word would be he. The second one would be apostrophe s. Then spending, 7, and so on. So we'd convert that into a list of shorter strings where each string is a word. And instead of word, we often say token. So for MADI datasets, if you download the dataset, NLP dataset from the web, this step has often been done for you already. But if you were to apply this on where you would extract by yourself some text data from the web, for instance, you would have to go through that step. For English and for French, usually just splitting words or tokens based on by essentially splitting at spaces and also separating punctuations. So for instance, we notice here that the dot here is actually separated as its own token, and if there had been a comma also, it would be considered its own token. So if we just use these two simple rules, separate at spaces and make punctuations their own token, then for English and French, that usually works fine, and we've been able like this to essentially separate everything into words. It's not as much true for other language, but for English and French, that works well. And there are some other languages where that works well. But we have an example here where, for instance, maybe what we would want actually is consider San Francisco as a single word, a single token. And if you wanted to do some more fancier pre-processing like this, you need to define some rules where you would identify that the space here, for instance, is not something that should separate the token into two. Okay, but just keep in mind, and in general, just separating by spaces is often sufficient, in particular for English and French. Next, we often lemmatize the tokens, that it would put them in some sort of standard form where we remove some usually syntactic information that is contained in the words. So for instance, we could take the word he and just remove the capital letter, so uncapitalize it. We could also take some verbs and actually put them in a more standard form. We could take numbers and just replace them by some arbitrary token. Here I've chosen the token number, just to say that this was a number, and past this step you just don't know which number it was. We could remove plurals, so days converted to day, and so on. So the specific kind of lemmatization that you might want to do for a particular problem will vary. Essentially what you want to do is remove variations of words that are not relevant for the task you want to solve. So if knowing that this is 7 and this isn't just an arbitrary number is important, then you'll want to keep 7 here. In the same way, if knowing that a noun, for instance, was singular or plural is important, then don't remove the plural. Just keep it in its original form in the original text. Okay, so that's lemmatization. And then what we'll do is that we'll now convert all of these tokens, which are strings, into an integer ID. And the way we'll do that is that we'll first come up with a vocabulary, which is a list of words that we are willing to recognize and distinguish. And so this vocabulary, we can think of it as a big long list of words. And then once we've made up this list, then we can associate each word in that list or each token to a unique ID. So for instance, the first one could be ID 1, the second one ID 2, 3, and so on. So how do we come up with that list of words? There are different criteria that we can use. We can just pick the most frequent words in the data set that we've collected. So we take all the words that have a frequency of at least 5, or if we want to limit the number of words, if we know the number of words we're willing to distinguish, we could say we'll take the 100,000 most frequent words. So that's a very general rule, which is often used. Sometimes also we decide to ignore some quote-unquote uninformative words, which we define using a short list. So for instance, we could remove articles like the or there might be other words which are not useful to recognize in the text for the problem that we want to solve. And at the end, then for all the words or tokens that are not in our vocabulary that we've defined, then all of these other words will be mapped to a special out-of-vocabulary ID. So at the very end of our list, we can think of it as there being an extra word, OOV, for out-of-vocabulary, and then this one will take the last ID in our list of IDs. So if I had, say here I had 9 words, then this would take ID 10, for instance. So again, depending on the problem, the type of vocabulary we want to define, the rules that we want to choose for selecting which words we want to distinguish and associate a unique ID to is going to vary. And in practice, the vocabulary size can actually be quite big. It can be as little as around 10,000 or as high as 250,000 or even more. So here's an example of the last preprocessing step. So we have this list of tokens that have been lemmatized, and then imagine I've defined this vocabulary here where the is associated with the ID 1, N to 2, and so on until OOV, which is associated with the ID 5. Then I take the and I replace it by 1, the integer 1, because the has the ID 1, and cat in the list is not present, so we'll map it to the ID of OOV, so that's why we have a 5 here. Then N is going to take the ID 2, the 1 again, and then dog, which has the ID 3, is going to be associated with 3, and so on. So for the rest of the videos, whenever we're going to refer to some word IDs, often I will use this symbol, W. So we can think of W as a categorical feature that describes the original word. It's essentially a feature description of the original word. So for instance, we can think of 1 as being a feature, and it's a categorical feature because it corresponds to which category in many categories, where each category would be a different word in the vocabulary. So to which category does the correspond to? And we could imagine adding other features, and that's something we'll probably talk about in the following videos. But at this point now we have data which is taking a format which is more numerical, so that's going to be easier to deal with. And still, sometimes when I'm going to talk about and refer to W, I might say the word W, even though really it corresponds to an ID, but because it's just, at this point these categories do correspond to individual words, except for OV, which corresponds to any other word that's not in the vocabulary. So you know, talking about W as a word is not such a stretch, really. So so that's it for the preprocessing. That's the kind of preprocessing we'll assume that has been done for the data for everything else that follows in the next videos.